Imagine seeing light that has traveled 13.5 billion years, traversing the vast emptiness of space to reach your eyes. Light from a time when the universe was still a newborn, when the first galaxies were just beginning to ignite. This is not science fiction. This is what the James Webb Space Telescope is revealing to us today. With its unprecedented infrared vision, JWST is pulling back the curtain on the earliest moments of our cosmos, capturing images so detailed, so unexpected, that astronomers are still trying to wrap their heads around them. Just recently, Webb has shown us galaxies that existed barely 280 million years after the Big Bang, galaxies that are far brighter, far more massive, and far more complex than anyone imagined. It has revealed ancient galaxy clusters forming earlier than our theories predicted, and even caught comet-forming crystalline dust spiraling away from newborn stars, giving us a glimpse into how planetary systems like our own begin to take shape. So, the question is, what secrets from the very dawn of the universe is James Webb uncovering right now? What cosmic stories are waiting to be told in the light that has traveled billions of years to reach us? If you want to witness these astonishing discoveries up close, make sure you subscribe to Evolvex, hit that like button, and share this journey with anyone who dreams of exploring the universe, because what we're about to see will completely change the way we look at the cosmos. Anomaly Z14 Galaxy Discovery. When we talk about peering back into the dawn of the universe, we need to understand what makes the James Webb Space Telescope so revolutionary. The Webb telescope was designed to do something no other observatory has done before: look deeper into space and further back in time than ever thought possible by observing in the infrared spectrum. Infrared light allows Webb to see through vast clouds of cosmic dust that block visible light and hide the earliest stages of galaxy and star formation. Unlike the Hubble Space Telescope, which mostly saw invisible and ultraviolet light, Webb's larger mirror and sensitive infrared instruments act like a time machine, letting us watch the earliest chapters of cosmic history play out in real time. This ability to see through dusty regions and detect faint red-shifted light is what pushes Webb beyond its predecessors. Where Hubble once gave us deep field images filled with thousands of galaxies, Webb takes us billions of years earlier in the universe's life. Its advanced cameras and spectrographs capture light that has been stretched by the expansion of space itself, revealing objects whose light has been traveling across the universe for more than 13 billion years. When you consider what Webb can do, it's not just an upgrade from Hubble, it's a whole new way of observing the cosmos, opening a window into epochs we could previously only imagine. And speaking of seeing back in time, one of Webb's most incredible achievements yet has been the discovery of the most distant galaxy ever observed, known by its scientific designation MOEM Z14. This tiny but intensely luminous galaxy existed a mere 280 million years after the Big Bang, at a time when the universe was still in its infancy, less than 2% of its current age. The light from MOEM Z14 has been journeying through expanding space for about 13.5 billion years before it finally reached Webb's infrared instruments, allowing us to see what the universe looked like when it was barely a cosmic toddler. What makes MOEM Z14 truly jaw-dropping is not just its distance, but its surprising brightness and composition. Early theories of galaxy formation predicted that the very first galaxies would be faint, small, and chemically primitive. Instead, Webb found MOEM Z14 to be brighter and more chemically enriched than expected, clues that early star formation and the production of heavier elements was happening much earlier and more efficiently than theory had suggested. This pushes astronomers to rethink how quickly the first stars and galaxies assembled after the Big Bang, and suggests that the dawn of structure in the universe was a far more dramatic and active period than we once believed. Beyond rewriting records, MOEM Z14 challenges our models of cosmic evolution. Its existence so close to the beginning of time means that galaxy formation processes must have been underway earlier and faster than the best simulations predicted, inviting scientists to refine their models or even question fundamental assumptions. In the coming years, as Webb continues to survey the universe's first epochs, we are likely to see even more discoveries that force us to confront the gaps in our understanding of how galaxies and ultimately the universe itself came to be. Breaking theories. Just when we thought we had a handle on how the universe grew up, the James Webb Space Telescope teamed up with NASA's Chandra X-ray Observatory and served up one of the most surprising discoveries yet: a galaxy cluster in the process of forming when the universe was barely 1 billion years old. This emerging assembly of galaxies still in its cosmic cradle is what astronomers call a protocluster, and it has been spotted at a time when most theories said such massive structures simply shouldn't exist yet. This young protocluster, identified in the JWST Advanced Deep Extragalactic Survey (JADES) and often referred to as JD's ID1, contains at least 66 potential galaxies bound together by gravity in a region of space just a little over a billion years after the Big Bang. Its total mass is equivalent to roughly 20 trillion suns, a truly staggering figure for such an early chapter of cosmic history. What makes this even more remarkable is the detection of hot X-ray emitting gas permeating the structure, a hallmark of more mature galaxy clusters that was previously thought to take billions of additional years to develop. The universe was already bustling with cosmic cities earlier than we ever imagined, and this discovery is forcing scientists to reassess how quickly large-scale structures can assemble. Traditional models of cosmic evolution predicted that galaxy clusters, the largest gravitationally bound structures in the universe, would take much longer to form, instead revealing a dynamic process that wasn't clearly understood before. In the blazing inner regions of the disk, roughly where terrestrial planets might form in a solar system, the crystals are made during energetic outbursts. Then, powerful stellar winds and outflows act like a cosmic conveyor belt, carrying them far out into the icy outer disk, potentially seeding the raw materials that will become comets. This discovery is important because crystalline silicates have been found in comets in our own solar system, but until now, astronomers didn't fully understand how they could form in hot inner regions and then reside in cold outer zones. Webb's observations show that the dust that eventually builds planets like Earth and that icy material that comets carry is visible here for the first time, traveling across space in a story of creation written in light. Why are these discoveries shocking? The discoveries we've seen from the James Webb Space Telescope are more than just visually stunning, they are rewriting the story of the early universe. MOEMZ14, the farthest galaxy ever observed, challenges the assumption that galaxies in the first few 100 million years would be small, faint, and simple. Instead, Webb shows us galaxies that are bright, massive, and chemically rich, suggesting that star formation and the creation of heavy elements happened far more efficiently than our models predicted. This is a universe that is growing up faster than anyone expected. If the first galaxies formed this quickly, what other early cosmic phenomena have we been missing all along? The early galaxy cluster JD's ID1 adds another layer of surprise. Its assembly less than a billion years after the Big Bang, containing dozens of galaxies, demonstrates that large-scale structures were forming astonishingly fast. Previous theories suggested that such cosmic cities would take billions of years to develop, but Webb reveals a universe bustling with gravitationally bound systems while still in its infancy. It's a humbling reminder that the cosmos is far more dynamic and efficient than we often give it credit for. Even in the more intimate details, Webb continues to astonish. The crystalline dust around newborn stars, traveling outward from the inner disk to seed future comets and planets, shows that the building blocks of solar systems can be both rapidly created and widely distributed. These findings offer a glimpse into processes that shaped our own solar system billions of years ago, proving that Webb is not only revealing the distant universe, but also helping us understand the origins of our planetary home. What makes all of this possible is Webb's infrared vision, which allows it to peer through clouds of cosmic dust and detect the faint, stretched light of objects billions of light years away. Without infrared capabilities, the universe's first galaxies, its earliest clusters, and the fine dust of planetary nurseries would remain hidden from our view. Webb is giving us not just pictures, but a new lens on reality, revealing a universe that is simultaneously stranger, more beautiful, and more complex than we imagined. If the universe formed this fast, how many other secrets lie just beyond the reach of our telescopes, waiting to reshape everything we think we know? The wow factor. The James Webb Space Telescope doesn't just capture data, it paints the universe in colors, patterns, and structures that take your breath away. Its images reveal glowing galaxies stretching across the cosmos, swirling star-forming regions, and intricate clouds of interstellar dust that look like cosmic brushstrokes on the canvas of space. These aren't mere photographs, they are windows into the processes that have shaped the universe over billions of years. Each frame is alive with motion, energy, and the quiet drama of creation unfolding on scales that are almost unimaginable. Consider the spectacular collisions of galaxies captured by Webb, where spiral arms twist and intertwine in a slow celestial dance, sparking waves of new star formation. The telescope's sharp infrared vision allows us to see through the dust that normally hides these interactions, revealing the intense starburst regions and energetic cores that mark these cosmic encounters. It's a glimpse into the chaos and beauty that drives galactic evolution, showing us that even destruction can be a form of creation. Webb has also turned its gaze closer to home, capturing the auroras of Jupiter in stunning detail. These luminous displays, far more intricate than ever seen before, illuminate the gas giant's magnetic dance and the charged particles streaming from its moons. It's a reminder that even within our own solar system, there are natural wonders so vast and powerful that they make us feel small, yet connected to the greater story of the cosmos. Finally, Webb's deep field surveys reveal thousands of galaxies packed into tiny patches of sky, each one a world of stars, planets, and potential life. These images, stretching billions of light years across space and time, are more than just pretty pictures. They are glimpses into the universe's own story, showing how matter organizes itself, how galaxies evolve, and how the cosmic web stretches across the void. Panning across these images or animating their growth over cosmic time is like watching history unfold, frame by frame, across the universe itself. Every image from Webb tells a story of creation, movement, and transformation. They remind us that the universe is alive, dynamic, and far stranger than we could ever imagine. These are not just images, they are bridges to understanding our cosmic origins, connecting us emotionally and intellectually to the universe that birthed us. How does this change astronomy? The James Webb Space Telescope is not just giving us breathtaking images, it is forcing astronomers to rethink the fundamental rules of how the universe formed. Discoveries like the farthest galaxy MOMZ14 and the ancient protocluster JD's ID1 challenge decades-old cosmological models, showing that galaxies and large-scale structures formed much faster and earlier than previously believed. Our simulations and theories had predicted faint, small, and slowly evolving early galaxies. Yet Webb reveals bright, massive, and surprisingly complex structures in the first billion years. We're seeing things that were once thought impossible. These observations suggest that early cosmic activity was far more intense than models had accounted for. The discovery of massive galaxy clusters forming just a billion years after the Big Bang tells us that gravity and star formation were operating at astonishing speeds. Similarly, the chemical richness of MOMZ14 implies that heavy elements were already being synthesized at rates that challenge our understanding of early stellar evolution. Each new discovery paints a picture of a universe that is surprisingly dynamic, organized, and bustling with activity much earlier than anyone expected. The excitement this has generated is global. Astronomers and cosmologists are revisiting their models, running new simulations, and planning follow-up observations to better understand these early epochs. The Webb telescope is opening doors to questions we didn't even know to ask, from how galaxies assemble to how stars and planetary systems emerge in the first billion years. Each image and spectrum brings new insights, and with each discovery, the scientific community and the world watches in awe as our understanding of the cosmos evolves in real time. Future discoveries and expectations. If the discoveries of the past year are any indication, the James Webb Space Telescope is just getting started. Scientists are already planning deeper surveys and targeted observations, aiming to uncover the universe's very first stars, the elusive Population 3 stars that ignited the cosmic dawn. These primordial stars burned hot, fast, and brightly, creating the first heavy elements that seeded future generations of galaxies. Detecting them would give humanity a direct glimpse into the birth of starlight itself. Beyond the first stars, Webb is expected to reveal even more distant galaxies, potentially pushing the limits of our observational reach further than MOMZ14. Each new discovery will help scientists understand how galaxies assembled so rapidly, how chemical elements spread through the cosmos, and how the cosmic web formed in the universe's first billion years. Every distant galaxy Webb finds is like a time capsule, holding secrets of the early cosmos waiting to be decoded. Closer to home, Webb is also poised to revolutionize our understanding of planetary system formation. By observing the disks of gas and dust around young stars in exquisite detail, it can track the creation of planets, asteroids, and comets in real time. These observations will shed light on the origins of our own solar system and the diversity of planetary systems across the galaxy. If the first year has been this mind-blowing, imagine what's coming next as Webb continues its journey across the cosmos. The future is full of anticipation. With each new observation, Webb brings us closer to answering some of the oldest questions in astronomy. How did the universe evolve? Where did the first stars and galaxies come from? Are planetary systems like ours common? Stay tuned, because the story of the universe is still unfolding, and James Webb is leading the way into the unknown. As we come to the end of this journey through the cosmos, it's hard not to feel awe at what the James Webb Space Telescope is revealing. From the farthest galaxy ever observed, MOM Z14, to the ancient galaxy cluster forming just 1 billion years after the Big Bang, and the comet-forming crystalline dust swirling around newborn stars, Webb is showing us a universe more dynamic, complex, and beautiful than we ever imagined. We're witnessing the universe like never before, peering into its earliest moments and understanding the processes that created the galaxies, stars, and planets we see today. Now it's your turn. Which discovery blew your mind the most? Let us know in the comments below, and don't forget to subscribe to Evolvex, hit like, and share this cosmic journey. The universe is just getting started, and Webb is leading the way into mysteries that will keep astonishing us for years to come.